Today I'm going to introduce you to one of the fundamental applications of derivatives. It's called related rates. And we're going to spend several days on related rates and look at a bunch of different typical problems about related rates. But the reason why we study them in Calc 1 is because with a derivative is calculating the rate of change of something. And with related rates, we have two or sometimes more than two things that are changing at different rates. And what we have to do is calculate the rate of change of one thing, which depends on another thing. So let me give you an example of what I mean by that. Let's say you're filling up a swimming pool. And you know how fast the water is coming out of your hose. And what you want to calculate is how fast the water level in the pool is rising. You know one rate, right? You know the rate of the water coming out of the hose, but you want to determine the other rate. You want to figure out how fast, like how many inches per minute or something like that is this is the water rising. These rates are called related rates because one depends on the other. The faster the water is poured in, the faster the water level will rise. And so we're going to study some typical related rates problems. And what we're going to be given is a rate that's unchanging over time. So a rate of change that is unchanged, the rate itself is unchanging over time. But the rate that we have to figure out is changing over time. And what our job is determine this rate that's changing at one particular point in time. All right, there's a step-by-step method to solving related rates problems. I'm not going to go into this today because I want to keep the video relatively short because you do have a textbook set of problems to do tonight. But I want you to know the things that you need to know. You need to have memorized that I don't think you've had to have memorized before in the past. So let me just jot down some things that over the next few days, hopefully you'll get a chance to memorize these. Some of them are pretty easy, and you've already learned them. So the things that you need to memorize, you need to know the circumference of a circle. And you're probably all saying, oh, that's pretty easy. That's 2 pi r. You also have to know the area of a circle. And you probably are all saying, oh, that's easy. That's pi r squared. And you have to know a lot of different volume problems because a lot of our related rates problems talk about the volume of something. So I don't know if anybody's noticed over on my side wall, but I've got a bunch of volume formulas over there. I'll be taking these down when you need to take a quiz or a test on them. But the volume of a cube is equal to side squared. That's probably from elementary school. You remember that. And a rectangular prism, which I'm just going to call a box, That's length times width times height. That's pretty easy. A cylinder. A cylinder has a circular base, and it has sides that are perpendicular to this base. So the volume of a cylinder is just the area of the circle, or the area of the base down here, times the height. So you can call that pi r squared times height, if you want to talk about that as the height and you know what the radius is. Or in other words, it's just the volume, or the area of the base times the height. And that will also do you well if you are presented with a trough problem. A trough is usually a rectangular type object that looks like this. And a lot of times there's water in this trough, but you need to know the volume of a trough. Well, the volume of a trough, if you want to turn the trough up on its end, you kind of can think about it the same way as a cylinder. If you know the area of this base, all you have to do is multiply it by the height. And so you'll be given all of the information you need to find the volume of a trough, but you have a height of a trough from the top to the bottom. And you'll be given the length of this trough, which I'll call L. And you'll also be given the width of this trough, which is the length of this triangular section. So you just do the area of this triangle, which is 1/2 base times height. And this base I'll call W for width. That's this part of it. So the area of the triangle is 1/2 base times height. And the volume of this trough is 1/2 base times height times the length. So that's another thing. A cone, well, first of all, let's do a sphere. A sphere is just a ball, or sometimes we have balloon problems where you're blowing air into a balloon and you want to find the rate of change of maybe the radius of this balloon, depending on how quickly or what the rate of air is going into or coming out of the sphere. So the volume of a sphere is equal to 4/3 pi r cubed, which is it's an interesting formula, because if you take the derivative, I want you to tell me what you'd get if you take the derivative of the volume of a sphere. You also have a cone with a circular base. And the cone, the volume of a cone is 1/3 times the area of this base, which is pi r squared, if you know the radius of it, times the height. So you can just call this 1/3 times the base times the height, which is the same thing if you have a rectangular pyramid. A rectangular pyramid has a rectangular base, usually it's square, and then it has, if I could draw this right, it has sides that come up like this, and you studied this in geometry. But the volume of a rectangular pyramid is the same thing as the rectangular cone, or I'm sorry, as the cone. You find out what the volume of this base is. And if it's a square, it's just sides squared, or if it's a rectangle, it's length times width. I'll call this length times width. So the volume of this would be, again, 1/3, just like the cone, because this is kind of coming in here. 1/3 times length times width times the height. And this has a particular height from bottom to top. So I think, let's see. I think that's probably about it for today, all the volume formulas that you need to know. And we'll get into some specific problems, I guess, on the next video. So have a great night.